Mustangs, welcome back to another edition of No Hair, No Problem. Rosenwald here with some notes on using the unit circle, and we're working on section 4.2 related to trigonometry. While you're doing this unit, or this section, I recommend that you have the unit circle available because I'm going to be doing quick references to different points that are on the unit circle, and I'm not going to keep drawing it. We'll just reference it really quickly, so I have that available, okay? All right, so let's get started here. First and foremost, we're going to be talking about, before we dive into the unit circle, we're going to add one little additional problem to this, if you will, and it relates to the idea of arc length when we're talking about a circle that's in degrees, and arc length when we're talking about a circle that's in radians. What you should remember is that the length of an arc, now remember when we're talking about a circle and we're talking about the arc, we're talking about that length on the outside of the circle, right? So when we look at a circle here, if I was to say what's the length of an arc is that portion. It's like that little portion of the circle that's there. Well, in order to do that, there was a little formula that you learned way back in geometry that said, let's take whatever angle is given to me. So it's a portion of the circle. So let's just say, hypothetically, we look at this triangle, or this circle, and we've got this angle that's right here. I don't know what it is. It could be 50, 60, 80, whatever. It could be some angle. It doesn't matter. It's an angle out of 360 because it's a portion of 360 degrees, right? So then what we know is that that length of it, the total distance around is the circumference, right? So the circumference is 2 pi r. So it was always the angle over 360 times 2 pi r. And so what we're working in now is we're on a unit where we're talking about radians instead of degrees. Well, how do we convert this over to a new formula that uses radians instead of always having to use angles and convert it back to radians? Here's how. We'd start with the formula we know, and we'll call S the arc length. Just for the sake of it, we'll call S the arc length. And what we know is that the 2 and the 360 that we see in here, this 2 and this 360 can simply reduce, right? So that's going to leave me with just a pi over 180. So if I was to cancel out the 2 and reduce the 360, it's going to leave me with a 180. Now the next thing we know is that when I am doing a conversion from angles into, from degrees into radians, we always multiply everything by 180 over pi. So if we multiply everything by 180 over pi, what's going to happen is these 180s are going to cancel each other out, and these pi's are going to cancel each other out. And what we're left with is a formula where we have S is simply going to be equal to theta times r. And theta is whatever your angle is as long as it's in radians, okay? So how do we use that for a problem like this? Well, it says find the length of an arc that is intercepted by a central angle of 1/8 radians in a circle of radius 24 inches. Well, the formula is S is equal to theta times r. Again, theta is your angle in radians, which in this problem we've already got our angle in radians. And then the radius of this is 24. So we're just going to go 1/8 times 24, which means my arc length is just going to equal 3 inches. Okay? So where can we actually utilize something like this? Well, for when you're sitting around, you're wondering how big is your pizza and the perimeter of it, because we all do that when we're reading, right? And if I was to say, find the perimeter of a 45-degree slice of a large 10-inch radius pizza. Well, draw the pizza. We got a pizza, two radius of it, and then we've got like that curved portion where the crust is at. We know the radius of each portion is 10. We need to know how big is that arc that's there, okay? Well, our formula is S is equal to theta times r. That's our normal formula. Well, in this case, I'm given 45 degrees as my angle, but I want to convert this over to radians. And so if I do that, we know that 45 degrees is the same as that pi over 4. That's a value that's on our unit circle in case you forget. So what that means is that if we were to try to find the entire distance around this, we've got this radius right here, we've got this radius right here, and then we've got this portion right here. All three of those together are going to be added, and that means we're going to have 10 plus 10 plus the pi over 2, which just simplifies to 20 plus 5 over 2 pi. So now it says, we'll find the perimeter of the entire pizza. It's not just a portion, now we're finding the whole thing. Well, the word for that is circumference. And the circumference of the pizza is just 2 pi r, which if we know the radius is 10, is again just going to equal 20 pi. Okay? All right, so let's get down to the nitty-gritty of actually using the unit circle to find all the trig functions. So what we know so far in this is we know that sine, cosine, and tangent is just SOHCAHTOA, right? Well, what we've got is their counterparts, which is that when we have a sine, the reciprocal is equal to cosecant. You can see that we've got the hypotenuse and opposite right here, and we've got the hypotenuse and opposite right here. They're just reciprocals of each other. When we look at cosine, we got adjacent and hypotenuse, and then for secant, we got hypotenuse adjacent, just reciprocals. Okay, and then when we look at tangent, we're talking about opposite adjacent, and then adjacent over opposite. And so something else to recall, which we're going to come back to later on, is we have this phrase that says all students take calculus. And when we're doing these, what this means is that all of the trig functions are positive in the first quadrant. Only sine is positive in the second quadrant, only tangent is positive in the third quadrant, and only cosine is positive in the fourth quadrant. But it's not just that sine, tangent, and cosine are positive in those quadrants. Their reciprocals are also going to be positive because we're not changing the signs. Okay? So let's dive into these. And again, unit circle, we're going to reference these very quickly. Okay? It says to evaluate the 6 trig functions based off of the angle that's given. So if we say pi over 6, we're looking at that 30-degree angle. The coordinate there, oh, and recall, sorry, this is important that we recall. We talked about this previously, that to make things faster with the unit circle, that y is sine of theta, x is cosine of theta, and tangent is y over x. Again, this only applies in a unit circle, okay? That's because when we divide by the radius is 1, and so that y divided by 1 that would normally take place is just a y. And the x divided by 1 is just an x. This only works for a unit circle, okay? So when we're talking about the sine of pi over 6, here's what we're referencing. At pi over 6, the coordinate for that is going to be root 3 over 2 and then 1/2. So if I say, well, what's the y value there? It's just 1/2. What's the x value? It's root 3 over 2. Okay? Now when I do the tangent, this one's a little wonky. We're going to take that 1 and the root 3, and we're going to focus on those. I don't pay attention to the 2's, because every time I deal with these fractions, those 2's would cancel themselves out. Here's why. If I was to do 1/2 on the top, that's your y value, and root 3 over 2 on the bottom, if I multiplied both the top and the bottom by 2, the 2's cancel out, and we're just left with 1 over root 3. If I rationalize this, it's root 3 over 3. Now again, what I just said there was that 1/2 divided by root 3 over 2 can be written as 1/2 divided by root 3 over 2, which means we have 1/2 times 2 over root 3. And that's why those 2's cancel right there. Okay? So that's why you'll see me never actually pay attention to those 2's when we're going through and doing these. I only focus on the numerators there. Okay? So 1 over root 3 simplifies, and it's just root 3 over 3. So now to find their counterparts, cosecant, secant, and cotangent, we're just going to take the reciprocals. So the reciprocal of 1 over 2 is just 2 over 1. The reciprocal of root 3 over 2 is just 2 over root 3. The reciprocal of root 3 over 3 is just root 3. That's, again, if we rationalize that, or we can even look simply at this part right here before we simplified it, that 1 over root 3, if I took the reciprocal, is just going to equal root 3. Okay? All right, let's go ahead and look at 5 pi over 4. When we're looking at 5 pi over 4, you can see that that coordinate is at 225 degrees, which has a coordinate of negative root 2 over 2 and then negative root 2 over 2. Okay? And so the y value there is negative root 2 over 2. Cosine is negative root 2 over 2. Anything divided by itself, y divided by x, because this is x, this is y. Anything divided by itself is just going to equal 1. Let's take the reciprocals of each of these. Negative 2 over root 2. Rationalize it. We'll multiply both the top and bottom by root 2. And then we simplify, we get negative root 2. Same thing for this one, obviously, because we have the same values here. So these two should also be the same. Okay? And then the reciprocal of 1, well, if it's 1 over 1, it's just going to equal a 1. All right, let's move on to the next one. When we're talking about negative angles, you can go ahead and use coterminal if you want. And what we can do is we can add 6 pi over 3, because that's equal to 2 pi. Remember, 6 divided by 3 is 2 pi. And if I do that, I'm looking at 5 pi over 3. Where we see 5 pi over 3 is right over here, and the coordinate at that spot is going to be equal to 1/2 and then negative root 3 over 2. You could have also done, since we know that positive pi over 3 is this direction, right? Well, I could have done negative pi over 3 going to this direction. And what that means is that when we look at the pi over 3 right here, this is at 60 degrees, right? Because we know it's 60 degrees. Well, if I go 60 degrees the other direction, that's going to put me at that 300 degree mark on the unit circle. Okay? So let's go ahead and use each one of these values. The y value is negative root 3 over 2. The x value is 1/2. And then y over x, again, let's focus on the numerator. Negative root 3 divided by 1 is just going to equal negative root 3. Okay? Take the reciprocals of each of these. We get negative 2 over root 3. If we rationalize, it's negative 2 root 3 over 3. Take the reciprocal of 1 over 2. It's just 2 over 1. And take the reciprocal of that. It's just negative 1 over root 3 or negative root 3 over 3. Okay? All right, let's look at a quadrantal value, which is pi. Pi, when we look at that coordinate right there, is going to be right at this spot. Okay, and that coordinate there is the negative 1, 0. Nothing changes. Just because it's a pi doesn't matter. We're still going to be able to do this. The sign of pi is just equal to 0. That's the y value. X value is negative 1. And then we do 0 divided by negative 1 is just going to equal 0. Take the reciprocal. Now be careful with these. If you think about this fraction, it actually says 0 over 1. So the reciprocal of 0 over 1 is 1 over 0, which is just going to be an undefined value. Reciprocal of negative 1 is just negative 1. And then again, since we have a 0, the reciprocal of 0 is just 1 over 0 or undefined. Okay? All right, next one here, 480 degrees. So the problem with 480 degrees is not on my unit circle. So what do? Well, this is where we take away 360 degrees from it. We're going to take away one revolution of it, okay? And what that does is that gets us to 120 degrees. That's a coterminal angle. Remember that 480 degrees and 120 degrees are in the exact same location. They're coterminal. And so if we looked at 120 degrees, that coordinate is at negative 1/2 and then root 3 over 2. So the sine of 480 is that y value. The cosine is the x value. And then the tangent of this is, again, focused on the numerator, root 3 over negative 1, which will just be negative root 3. Reciprocals of everything, and these are the values that we get. Okay? Now, what do we do when we get these values that don't actually fit on our unit circle? There's no 6 pi over 5. That denominator 5 throws everything off. And so what happens is we have to use our calculator. Well, the reciprocal functions, the cosecant, secant, and cotangent, they're not on our calculator. So the only way that we can actually go about using these is if we use the reciprocal of the functions themselves. So if we're looking at secant of 6 pi over 5, the reciprocal of this is going to be 1 over cosine of 6 pi over 5, the reciprocal. This you go ahead and throw into your calculator. You have to make sure that you are in radians when you're doing this because my question is in radians. If you're in degrees, you're going to get the wrong answer. And we end up with negative 1.2 radians. Okay? All right, next one. Finding the ratios given one ratio. All right. So these are the problems where it's like you have to piece together a little puzzle. Okay, and it's not that complicated. We're just going to be drawing in terminal sides of a triangle here. You'll see in a second. So first thing we have to do is realize that they're giving me some information. Okay, they're telling me that the cosine of theta is 4 over 7. Now when you look at that, this is a positive value. And the question is, where is cosine positive at? Well, cosine is always going to be positive in this quadrant and in this quadrant. Okay? When we look at the sine of theta, they tell us that it's less than 0, which means if it's less than 0, it's obviously going to be a negative value. Well, where is sine negative? Sine is negative in the third and the fourth quadrant. It's positive in that second quadrant. And so when we look at this, we now see that there's an overlap. There's 2 dots in this section. That means all the information they've given us directs us into the fourth quadrant. So what we're going to do is we're going to draw a terminal side in the fourth quadrant. Okay? So now they're giving me the adjacent side here and the hypotenuse right here, because that's what cosine stands for, adjacent and hypotenuse. Let's draw my side perpendicular to the x-axis, not the y-axis. The adjacent side of my triangle here is going to be equal to 4, and my hypotenuse is 7. The common mistake that people do is they'll put the angle down here on the bottom, and remember, we're always putting angles when we're doing this. We're putting angles along by the origin there, okay? So there's my sides. I don't have my third side. So how do we find our third side? Well, we use good old Pythagorean theorem. So if we set up our Pythagorean theorem, we know that a squared plus b squared equals c squared. We get a squared plus 16 is equal to 49. We'll now have a squared is equal to root 33, and then we get a is equal to plus or minus root 33. Now this is an important detail because this is where people make a lot of mistakes. You can use a positive or you can use a negative. It just depends what we're dealing with in the problem. In this case, we're going down. In order to get to this point right here, we're going to be going down. Well, on a coordinate plane, down is not positive. Down is actually negative. So we have negative root 33 here. Okay. So now, if we're going to go ahead and take the sine and the cosine and the tangent of this, all we're doing is just good old SOHCAHTOA. Okay, we're just doing good old SOHCAHTOA, which means from this situation, not a unit circle situation, because this is not equal to 1, it's not a unit circle. We're just asking what's the sine, cosine, and tangent of this. So for the sine of my angle, we're going to go opposite, which is negative root 33, and my hypotenuse, which is 7. So negative root 33 over 7. For cosine of this, we're going to go cosine of the angle is the adjacent side divided by the hypotenuse, which is 4 over 7, which we already have in this problem given to us. Okay, tangent is opposite over adjacent. So here's my opposite side, here's my adjacent side. Opposite over adjacent would be negative root 33 over 4. Now we're done with the 3. We just take the reciprocals of each one of these. So it's going to be negative 7 over root 33, 7 over 4, and then negative 4 over root 33. That's it. I hope this helps, and I hope you guys understood it. Again, I did go a little quick, but that's because we're just utilizing the tool of the unit circle when we can. If you have any questions, please reach out. But otherwise, you guys don't forget to like and subscribe to my channel. You stay safe, stay respectful, stay responsible, and have a great day.